the p block elements. And after studying this unit, you will be able to appreciate the general trends in the chemistry of the elements of the group 15, 16, 17, and the 18. Learn the preparation property and the use of the dinitrogen and the phosphorus and some of their important compounds. Describe the preparation property and the use of the dioxygen and ozones and chemistry of the some of the simple oxides. Know the allotropic forms of the sulfur, chemistry of its important compounds, and the structure of the oxo acids. Describe the preparation properties and the use of the chlorine and the hydrochloric acid. Know the chemistry of the entire halogens and the structure of the oxo acids of the halogen. Enumerate the use of the noble gases. Appreciate the importance of the elements and their compounds in day-to-day life. Diversity in the chemistry. Diversity in the chemistry is the hallmark of the Diversity in the chemistry is the hallmark of the p-block elements, manifested in their ability to react with the elements of the F, D, and the F block as well as with their own. In the class 11, you have learnt about that the p-block elements are placed in the group 13 to 18 of the periodic table. Their valence shell electronic configuration is F2 NP1 to 6 except helium, which has a 1f2 configuration. The properties of the p-block elements, like that of the others, are greatly influenced by the atomic sizes, ion enthalpy, electron enthalpy, and the electronegativity. The absence of the d orbitals in the second period and in the presence of the d or the d and the f orbitals, which is in the heavier elements starting from the third period onwards, have significant effects on the properties of the elements. In addition, the presence of all the three types of the elements, metal, metalloids, and non-metals, brings diversification in the chemistry of these elements. Having learned the chemistry of the elements of the group 13 and the 14 of the p block of the periodic table in the class 11, we will learn the chemistry of the elements of the subsequent groups in this unit. Group 15 elements occurrences. Uh, Group 15 includes the nitrogen, phosphorus, arsenic, antimony, bismuth, and the moscovium. As we go down the group, there is a shift from the non-metallic to the metallic through the metalloid character. Nitrogen and phosphorus are non-metals, arsenic and antimony are metalloids, bismuth and the moscovium are the typical metals. And the occurrences. The molecular nitrogen comprises 28% of volume of the atmosphere. In the Earth crust, it occurs as a sodium nitrate NaNO3 called the chill saltpeter and the sodium nitrate called the Indian saltpeter. It is found in the form of the protein in the plants and animals. Phosphorus occurs in the minerals of the apatite family Ca9PO46 Ca2 Cx is equal to choline, bromine, bromine or the choline for choline or the hydroxide example fluoropeptide Ca9PO46 CaF2, which are the main components of the phosphate rocks. Phosphorus is an essential constituent of the animals and the plants matter. It is present in the bones as well as in the living cells. Phosphorus proteins are present in the milk and the eggs. Arsenic, antimony, and the bismuth are found on mainly as the sulfide mineral. Moscovium is a synthetic radioactive element. Its symbol is Mc. Atomic number is 115. Atomic mass 289, and the electronic configuration Rn 5f14, 6d10, 1f2, 1p3. Due to very short half-life and availability in the very little amount, its chemistry is yet to be established. Uh, Here, except for the moscovium, important atomic and the physical properties of the other elements of the group of this group, along with the electronic configuration, are given in table 7.1. Atomic and the physical properties of the group 15 elements. Atomic number, atomic mass, gram per mole, electronic configuration, ionization enthalpy, kilojoule per mole, electronegativity, covalent radius, ionic radius, melting point, boiling point, and the density. Trends of some of the trends Trends of some of the atomic, physical, and the chemical properties of the groups are discussed below. Electronic configuration. The balanced electronic configuration of these elements in NF2 and P3. The f orbital in these elements is completely filled, and the p orbitals are half filled, making the electronic configuration extra stable. Atomic and the ionic radii. The covalent and ionic in a particular state radii increase in the size down the group. There is a considerable increase in the covalent radius from n to p. However, Arsenic to the bismuth, only a small increase in the covalent radius is observed. This is due to the presence of the completely filled d and the f or the d or the f orbitals in the heavier members. Ionization enthalpy. Ionization enthalpy decreased on the group due to the gradual increase in the atomic size because of the extra stable half-filled p orbitals, electronic configuration, and the smaller size. The ionization enthalpy of the group 15 elements is much greater than that of the group 14 elements in the corresponding periods. The order of the successive ionization enthalpy as expected is delta H I sub delta H2 or delta H2 sub delta H3. Electronegativity. The electronegativity value in general decreases down the group with the increasing atomic size. However, amongst the heavier elements, the difference is not that much pronounced. And the physical properties, all the elements of this group are polyatomic. Dinitrogen is diatomic gas, while all other are solids. Metallic character increased down the group. Nitrogen and the phosphorus are non-metals. Arsenic and antimony metallites and bismuth is metal. This is due to decrease in the ionization enthalpy and increase in the atomic size. The boiling points in general increase from the top to the bottom in group, but the melting point increases up to the arsenic and then decreases up to the bismuth. Except nitrogen, all the elements show the allotropy. Chemical property, oxidation state and the trends in the chemical reactivity. The common oxidation states of these elements are -3 plus 3 and the plus 5. The tendency to use -3 oxidation state decreases down the group due to the increase in the size and metallic character. In fact, the last member of the group bismuth hardly forms any compound in -3 oxidation state. The stability of +5 oxidation state decreases down the group. The only well characterized bismuth 5 compound is BiF5. The stability of +5 oxidation state decreases and that of +3 state increases due to inert pair effect down the group. Besides +5 oxidation state, nitrogen exhibits +1, +2, +4 oxidation state also when it reacts with the night oxygen. However, it does not form compounds in the +5 oxidation state with halogens, and nitrogen does not have d orbitals to accommodate electrons from other elements to form bonds. Phosphorus also for +1 and the +4 oxidation states in some oxo acids. In the case of the nitrogen, all oxidation states from the +1 to +4 tends to disproportionate in the acid solution. For example, uh, HNO3 HNO2 से रिएक्शन HNO3 से हम लोग HNO3 प्लस H2O प्लस 2NO बना सकते हैं. Similarly, in the case of the Similarly, in the case of the phosphorus, nearly all the intermediate oxidation states disproportionate into +5 and the -3 both in the alkali and the acid. However, +3 oxidation state in the case of the arsenic, antimony and bismuth become increasingly stable with respect to the disproportionation. Nitrogen is restricted to a maximum covalency of 4 since only 4 1s and 3p orbitals are available for bonding. The heavier elements have vacant d orbitals in the outermost shell which can be used for bonding covalency and hence expand their covalence when the pF6-. Anomalous property of the nitrogen. Nitrogen differs from the rest of the members of this group due to the small size, high electronegativity, high ionization enthalpy, and non-availability of the d orbitals. Nitrogen has unique ability to form p-pi multiple bonds with itself and other elements having a small size and high electronegativity C and O. Heavier elements of this group do not form p-pi bonds as their atomic orbitals are so large and diffuse that they cannot have effective overlapping. Thus, nitrogen is used as a diatomic molecule with the triple bond and triple 1s and 2p between the two atoms. Consequently, its bond enthalpy 941.4 kJ per mole is very high. On contrary, phosphorus, arsenic, and the antimony form single bonds as pp, ss, and sp, while bismuth forms metallic bonds in the elemental state. However, the single NN bond is weaker than the single pp bond because of the high inter-electronic repulsion of the non-bonding electrons owing to the small bond length. As a result of the catenation tendency is weaker in the nitrogen. Another factor which affects the chemistry of nitrogen is the absence of the d orbitals in its valence shell. Besides restricting its covalency to 4, nitrogen cannot form d pi p pi bonds as the heavier elements can. Example, R3P-double or the R3P-double CH2 R is equal to alkyl. Phosphorus and arsenic can form d-pi bonds also with the transition metal. Then when their compounds like PCH2H53 and the AF6H53 act as the ligands. Reactivity towards the hydrogen. All the elements of the group 15 form the hydrides of the type EH3 where E is equal to NPAF or the bismuth. Some of the property of these hydrides are shown in table 7.2. These hydrides for regular graduation in the gradation in the property. The stability of the hydrides decreases from the NH3 to BiH3, which can be observed from their bond dissociation enthalpy. Consequently, the reducing character of the hydrides increases. Ammonia is only a mild reducing agent, while BiH3 is the strongest reducing agent among all the hydrides. Basicity also decreases in the order सबसे ज़्यादा BH3, उससे कम NH3, PH3, सबसे ज़्यादा NH3, उससे कम P3, फिर उससे कम FH3 और उससे कम SBH3 और सबसे कम BiH3. Due to the high electronegativity and the small size of nitrogen, NH3 exhibits high hydrogen bonding in the solid as well as the liquid state. Because of this, it has higher melting and the boiling point than of the PH3. Property of the hydrides group 15 elements. Melting point, boiling point, EH distance, HEH angle, and the heat of the formation kilojoule per mole, and the heat of the dissociation EH kilojoule per mole. NH3 का, PH3 का, AF3 का, AFBH3 का, and the BiH3 का. Reactivity towards the oxygen. All these elements form two types of oxides, E2O3 and the E2O5. The oxides in the higher oxidation state of the element is more acidic than that of the lower oxidation state. Their acidic character decreases down the group. The oxides of the type E2O3 of the nitrogen and the phosphorus are purely acidic. That of the arsenic and the antimony amphoteric, and those of the bismuth are predominantly basic. Reactivity towards the halogen. These elements react to form two series of halides, EX3 and the EX5. Nitrogen does not form pentahalide due to the non-ability of the d orbitals in this valence shell. Pentahalides are more covalent than the trihalides. This is due to the fact that in the pentahalides +5 oxidation state exists, while in the case of the trihalides +3 oxidation state exists, since element in the +5 oxidation state where will have more polarizing power than in the +3 oxidation state. Then the covalent character of the bonds is more in the pentahalides. All the trihalides of these elements except those of the nitrogen are stable. In case of nitrogen, only NF3 is known to be stable. Trihalides except BiF3 is predominantly covalent in the nature. Reactivity towards the metal. All the elements react with the metals to form their binding compounds using -3 oxidation state, such as Ca3N2 calcium nitride, Ca3P2 calcium phosphide, Na3S sodium arsenide, Zn3Sb2 zinc antimonide, and the Mg3Bi2 magnesium bismuthide. Uh, though nitrogen exhibits question. Though nitrogen exhibits +5 oxidation state, it does not form pentahalide. Give reason. Nitrogen pentahalide give region. Nitrogen with n बराबर 2 has s and p orbitals only. It does not have d orbitals to expand its covalence beyond 4. That is why it does not form the pentahalide. PH3 has lower boiling point than the NH3. Why? Unlike NH3, PH3 molecules are not associated through the hydrogen bonding in liquid state. That is why the boiling point of the PH3 lower than the NH3. In text question, why are pentahalides of the P, arsenic, Sb, and the bismuth more covalent than their trihalides? Why is BiH3 the strongest reducing agent among all the trihalides of the hydrides of the group 15 elements? Preparation. Dinitrogen. Preparation. Dinitrogen is produced commercially by the liquefaction of the fractional distillation of the air liquid. Dinitrogen boiling point 27.2 Kelvin distills out first, leaving behind liquid distills out first, leaving behind liquid oxygen boiling point 19 Kelvin. In the laboratory, dinitrogen is prepared by treating an aqueous solution of the ammonia collide with sodium nitrate. और रिएक्शन है कि NH4Cl प्लस NaNO2 रिएक्शन करेगा तो बनेगा N2 प्लस H2O और NaCl aqueous बनेगा. A small amount of the NO and the HNO3 are also formed in the reaction. These impurities can be removed by passing the gas through the aqueous sulfuric acid containing potassium dichromate. It can also be obtained by the thermal decomposition of the ammonium dichromate. और रिएक्शन है कि NH4 2Cr2O7 को हीट करने पर बनेगा N2 प्लस 4H2O प्लस Cr2O3. Very pure nitrogen can be obtained by the thermal decomposition of the sodium or the barium azide. रिएक्शन है कि BaN3 2 को रिएक्ट करने पर बनेगा Ba+3N2। Properties: Dinitrogen is colorless, odorless, tasteless, and non-toxic gas. Dinitrogen atom has two stable isotopes, N14 and N15. It has a very low solubility in the water. It has very low solubility in the water, 23.2 centimeter cube per liter of the water at 223 Kelvin and 1 bar pressure, and low freezing point, boiling point. Dinitrogen is rather inert at room temperature because of the high bond enthalpy and triple bond N reactivity, however, increases rapidly with the rise in the temperature. At higher temperature, it directly combines with the some metals to form the predominantly ionic nitrides with the non-metals covalent nitrides. A few typical reactions are Li plus N2 को हीट करने पर मिलेगा Li3N और Mg plus N2 को हीट करने पर मिलेगा Mg3N2. It combines with the hydrogen at about 723 Kelvin in the presence of a catalyst, however process to form the ammonia. और रिएक्शन है कि N2 प्लस H2 को एट 723 केल्विन पर हीट करने पर मिलेगा NH3 और हीट ऑफ फॉर्मेशन है -46.1 किलोजूल पर मोल. Dinitrogen combines with the dioxin only at a very high temperature at about 200 Kelvin to form the nitric oxide NO. और रिएक्शन है कि N2 प्लस O2 को हीट करने पर मिलेगा NO. Now, usage. The main use of the dinitrogen is in the manufacture of the ammonia and other industrial chemicals containing nitrogen. Example, calcium cyanamide. It also finds use where an inert atmosphere required. Example, iron and steel industry. Inert, diluent, or the reactive chemicals. Liquid dinitrogen is used as a refrigerant to preserve the biological materials, food items, and the pyrosurgery. Example, what are the reactions of the thermal decomposition of the sodium azide? Thermal decomposition of the sodium azide gives dinitrogen gas. और रिएक्शन है कि Na(N3) टूटेगा तो बनेगा Na+3N2. In text question, why is N2 less reactive? Why is N2 less reactive at the room temperature? Ammonia preparation. Ammonia is present in the small quantity in air and soil where it is formed by the decay of the nitrogenous organic matter. Example, यूरिया. और रिएक्शन है कि NH2CO NH2 प्लस H2O को हीट करने पर मिलेगा NH4 2CO3 और जिसको फिर से एक रिवर्सल रिएक्शन है कि NH3 प्लस H2O प्लस CO2 मिलेगा. तो ये रिएक्शन हो गया. On a small scale, ammonia is obtained from the ammonium salts which decompose when treated with the caustic soda or the calcium hydroxide. A reaction like NH4Cl plus CO2 gives the NH3 plus H2O plus CaCl2. NH4 2SO4 plus NOH gives the NH3 plus H2O plus Na2SO4. On large scale, ammonia is manufactured by the Haber process. N2 plus H2, N2 plus H2 gives the 2NH3. In accordance with the Le Chatelier principle, high pressure would favor the formation of the ammonia. The optimum condition for the production of the ammonia are pressure of 200 into 10 to the power 5 Pascal, about 200 atm, a temperature of 700 Kelvin, and the use of the catalyst such as the iron oxide with a small amount of the K2O and the Al2O3 to increase the rate of the attainment of the equilibrium. The flow chart for the production of the ammonia is shown in the figure 1.1. Earlier, iron was used as a catalyst with the molybdenum as a promoter. N2 plus H2 को कंप्रेसर में डालें 20 MPa पर. पंप में फिर कैटलिस्ट यहाँ पर है. Al2 कैटलिस्ट आयरन ऑक्साइड है Al2O3 प्लस K2O है एट 700 केल्विन पर और N2 प्लस H2 प्लस NH3 गैस N2 प्लस H2 लिक्विड NH3 यहाँ पर बन गया. Flow chart for the manufacture of the ammonia. और properties. Ammonia is a colorless gas with a pungent odor. Its freezing point, boiling point are 198.4 and 239.1 Kelvin respectively. In the solid and the liquid state, it is associated through the hydrogen bonds as in the case of the water, and that accounts for high higher melting and the boiling points than expected on the basis of its molecular mass. The ammonia molecule is trigonal pyramidal with the nitrogen atom at the apex. It has three bond pairs and one lone pair of electrons as shown in the structure. Ammonia gas is highly soluble in the water. Its aqueous solution is weakly basic due to the formation of the OH minus ion और रिएक्शन है कि ओ NH3 प्लस H2O लिक्विड NH4 माइनस आयंस प्लस NH4 माइनस आयंस NH4 माइनस आयन प्लस OH माइनस आयंस बनाता है. It forms the ammonium salts with acids, example NH4Cl, NH4 2SO4, etc. As a weak base, it precipitates the hydroxide hydrated oxide. In the case of the some metals, of many metals form the salt solution. For example, ZnSO4 plus NH4OH gives the ZnOH2 white precipitate plus NH42SO4, or FeCl3 plus NH4OH gives the Fe2O3 plus XH2O plus NH4Cl, जो कि क्या है, ब्रॉन PPT है. अब ये रिएक्शन है NH3 107.8 डिग्री और 101.7 पिकोमीटर पर. The presence of the lone pair of the electrons on the nitrogen atom of the ammonia molecule makes it a Lewis base. It donates the electron pair and form linkage with metal ions, and the formation of the such complex compounds find application in the detection of the metal ions such as the Cu2 plus and the Ag plus. Cu2 plus blue plus NH3 give the CuNH3 deep blue, और Ag plus plus Cl minus give the AgCl white PPT, और the AgCl plus 2NH3 give the AgNH3 जो कि है कलरलेस. ये रिएक्शन हो गया. फिर यूज क्या है, तो अमोनिया is used to produce various nitrogenous fertilizer, ammonium nitrate, urea, ammonium phosphate, and the ammonium sulfate, and in the manufacture of the some inorganic nitrogen compounds, the most important one being nitric acid. Liquid ammonia is also used as a refrigerant. Example 7.4. Why does NH3 act as a Lewis base? Nitrogen atom in the NH3 has lone pair of electrons which is available for the donation, therefore it acts as a Lewis base. In text question, you mention the condition required to maximize the yield of the ammonia. How does ammonia react with the solution of the Cu2 plus? Oxides of the nitrogen. Nitrogen forms a number of the oxides in different oxidation states. The names, formulas, preparation, and the physical properties of these oxides are given in table 1.3. फार्मूला जैसे डाई नाइट्रोजन ऑक्साइड या नाइट्रोजन 1 ऑक्साइड इसका फार्मूला है. फिर नाइट्रोजन मोनोऑक्साइड इसका फार्मूला है, इसका फार्मूला N2O, इसका फार्मूला है NO. फिर डाई नाइट्रोजन ट्राईऑक्साइड N2O3, नाइट्रोजन डाइऑक्साइड NO2, एंड नाइट्रोजन डाई नाइट्रोजन टेट्राऑक्साइड N2O4, डाई नाइट्रोजन पेंटॉक्साइड N2O5. Oxidation state of the nitrogen +1 +2 +3 +4 +5. कॉमन मेथड ऑफ प्रिपरेशन NH4NO3 को हीट करने पर N2O प्लस H2O मिला. और फिजिकल अपीयरेंस एंड केमिकल नेचर है कि कलरलेस है, गैस है और न्यूट्रल है. फिर जो नाइट्रोजन मोनोऑक्साइड है उसका रिएक्शन है कि Na2 प्लस FeSO4 प्लस H2SO4 को मिलाने पर Fe2SO4 प्लस NaHFO4 प्लस H2O प्लस NO मिला. और इसका प्रॉपर्टीज है कि कलरलेस गैस ये भी है, नाइट्रोजन मोनोऑक्साइड NO और न्यूट्रल है. और ये भी कैसा है, तो ये भी है जो न्यूट्रल है. फिर उसके बाद आता है डाइनाइट्रोजन ट्राईऑक्साइड N2O3. इसको रिएक्शन बनाने के लिए NO प्लस N2O4 को मिलाएं और हाई सुक्रिलिन पर, तो बन गया N2O3. और इसका जो प्रॉपर्टी है वो है कि ये है ब्लू सॉलिड है और एसिडिक है. फिर आता है PbNO2 को बनाने के लिए, नाइट्रोजन ऑक्साइड को बनाने के लिए PbNO3 को 673 केल्विन पर गर्म करने पर NO2 मिलता है, NO2 मिला और PbO प्लस O2 मिला. और इसका प्रॉपर्टी है कि ये ब्रॉन गैस है और एसिडिक है. फिर डाइनाइट्रोजन टेट्राऑक्साइड N2O4 कैसे मिलेगा, तो उसके लिए NO2 को फिर कूल करेंगे तो N2O4 मिलेगा. N2O4 को एक रिवर्सिबल रिएक्शन में कि हीट करेंगे तो NO2 मिल जाएगा. तो ये रिएक्शन इसका हो गया नाइट्रोजन डाइनाइट्रोजन टेट्राऑक्साइड का. और इसका जो रिएक्शन वो है कि कलरलेस है, सॉलिड है और लिक्विड और एसिडिक है. फिर N2O5 डाइनाइट्रोजन पेंटॉक्साइड के लिए HNO3 प्लस P4O10 को मिलाएं तो HPO3 और प्लस N2O5 मिल जाएगा. और इसका है कि ये कलरलेस सॉलिड है और एसिडिक है. Lewis dot main resonance structure and bond diameter of the oxides are given in table 1.4. A structure of the oxides of the nitrogen. तो ये हो गया। और बॉन्ड पैरामीटर्स है कि एन ये 113 पिकोमीटर, 119 पिकोमीटर और लीनियर है। फिर एन ओ, फिर ये है प्लेनर है। ऐसे देख सकते हैं कि N2 जो है वो है लीनियर है, NO जो है वो है NO जो है NO जो है वो NO जो है बस उसका उसमें कुछ है ही नहीं, बस ऐसे ही है। फिर N2O3 जो है वो है प्लेनर है, NO2 जो है वो है एंगुलर है, फिर N2O4 जो है वो है प्लेनर है, और N2O5 जो है वो भी है जो प्लेनर है। इस तरह से देख सकते हैं। N2O जो है वो है लीनियर है, NO जो है उसका मतलब इस तरह से स्टेट चेंज जैसा है। फिर N2O3 जो है प्लेनर है, NO2 भी है जो एंगुलर है, N2O4 जो है प्लेनर है, और N2O5 भी प्लेनर है। क्वेश्चन कि why does NO2 dimerize? तो NO2 contains odd number of the valence electron. It behaves as a typical odd molecule. On dimerization, it is converted to a stable N2O4 molecule with even number of the electrons. In text question, what is the covalence of the nitrogen in the N2O5? Nitric acid. Nitrogen forms oxo acid such as H2N2O2, hyponitrous acid, HNO2 nitrous acid, and HNO3 nitric acid. Amongst them, HNO3 is the most important. Preparation. In the laboratory, nitric acid is prepared by heating KNO3 or the NO3 and concentrated H2O4 in the glass retort. और रिएक्शन है कि NaNO2 प्लस H2O4 मिलाने पर NaHO4 प्लस HNO3 मिलता है। On a large scale, it is prepared mainly by the Ostwald process. This method is based upon catalytic oxidation of NH3 by the atmospheric oxygen. जैसे NH3 प्लस O2 को मिलाएं जो कि एयर से आया, और प्लेटिनम और RH गॉज कैटलिस्ट है 500 केल्विन एट 300 बार पर, तो NO बना और H2O बना। ये रिएक्शन हो गया। फिर इसके बाद the nitric acid does formed combines with the oxygen giving NO2। फिर उसके बाद जो NO है उसको O2 के साथ मिलाएं तो फिर NO2 बन गया, NO2। उसके बाद फिर नाइट्रोजन ऑक्साइड so formed dissolves in the water to give the HNO3। फिर NO2 प्लस H2O लिक्विड जो है मिलाने पर HNO3 प्लस NO बन गया, जो कि क्या है, गैस। No NO thus formed is recycled and aqueous HNO3 can be concentrated by distillation up to the 68% by the mass. Further concentrated to the 98% can be achieved by the dehydration with the concentrated H2SO4। और इसका प्रॉपर्टीज है, ये इसका स्ट्रक्चर हो गया जिसमें है 100 NO, ये HNO3 का स्ट्रक्चर ये हो गया, HNO3 है, HNO3 का ये स्ट्रक्चर हो गया। अब प्रॉपर्टीज है कि इट इज़ अ कलरलेस लिक्विड जिसका फ्रीजिंग पॉइंट है 241.4 केल्विन, बॉइलिंग पॉइंट 355.6 केल्विन। लेबोरेटरी स्पेसिफिक नाइट्रिक एसिड contains 58% of the HNO3 by mass and has a specific gravity of the 1.504. In the gaseous state, HNO3 gives as a planar molecule with the structure as shown. In the aqueous solution, nitric acid behaves as a strong acid giving hydronium ion and nitrate ions। और इसका जो रिएक्शन है वो जाता है HNO3 प्लस H2O, H3O प्लस NO3 माइनस। Concentrated nitric acid is a strong oxidizing agent and attacks most metals except noble metals such as the gold and the platinum. The product of the oxidation depends upon the concentration of the acid's temperature and the nature of the material undergoing the oxidation. Cu plus HNO3 give the CuNO3 plus NO plus H2O, और the Cu plus HNO3 concentrated give the CuNO3 plus NO2 plus H2O। ये रिएक्शन हो गया। उसके बाद जिंक reacts with the dilute nitric acid to give the N2O and with concentrated acid to give the NO2। Zn plus 10 HNO3 give the ZnNO3 plus H2O plus N2O, और Zn plus HNO3 concentrated give the ZnNO3 H2O, और यहाँ पर NO2 मिलेगा। तो ये इसका रिएक्शन हो गया दोनों को। उसके बाद फिर some metals example chromium, aluminum do not dissolve in the concentrated nitric acid because of the formation of the passive film of oxide on the surface. Concentrated nitric acid also oxidize non-metals and their compounds. Iodine is oxidized to iodic acid, carbon to carbon dioxide, sulfur to H2SO4, and phosphorus to the phosphoric acid. जैसे I2 प्लस HNO3 HiO3 प्लस HiO3 हो जाएगा, C प्लस HNO3 CO2 हो जाएगा, और F8 प्लस HNO3 H2SO4 हो जाएगा, फिर P4 प्लस HNO3 H3PO4 हो जाएगा, और सब में NO2 बनेगा और वाटर बनेगा। फिर आता है ब्रॉन रिंग टेस्ट। द फैमिलियर ब्रॉन रिंग टेस्ट फॉर द नाइट्रेट डिपेंड्स अपॉन द एबिलिटी ऑफ द Fe2 plus to reduce nitrate to the nitric oxide, which reacts with the Fe2 plus to form a bronze colored complex. The test is usually carried out by adding dilute ferrous sulfate solution to an aqueous solution containing nitrate ion and then carefully adding concentrated sulfuric acid with the sides of the test tube. A bronze ring at the interface between the solution and the sulfuric acid layer indicates the presence of the नाइट्रेट आयन इन द सॉल्यूशन, जिसका रिएक्शन जाएगा कि NO3 माइनस प्लस Fe2 प्लस 4H प्लस NO देगा और Fe3 प्लस और H2 बना देगा, Fe2 प्लस Fe3 बन गया, और FeH2O6 प्लस प्लस NO मिला के बनाएगा FeH2O5NO जो कि है ब्राउन कलर का। अब इसका यूज है कि द मेजर यूज ऑफ द नाइट्रिक एसिड इज इन द मैन्युफैक्चर ऑफ द अमोनियम नाइट्रेट फॉर द फर्टिलाइजर एंड फॉर द अदर नाइट्रेट फॉर द यूज इन द एक्सप्लोसिव एंड द pyrotechnics. It is also used for the preparation of the nitroglycerin, trinitrotoluene, and other organic nitro compounds. Other major uses are in the pickling of the stainless steel, etching of the metals, and as an oxidizer in the rocket fuels. Phosphorus allotropic form. Phosphorus is found in many allotropic forms, the important ones being the white, red, and the black. White phosphorus is a translucent white basic solid. It is poisonous, insoluble in the water, but soluble in the carbon disulfide and glows in the dark chemiluminescence. It dissolves in the boiling NOH solution in the inert atmosphere, giving pH 3. जैसे P4 प्लस NaOH प्लस H2 को मिलाएं तो pH 3 प्लस NaH2PO2 मिला, और ये इसका रिएक्शन है जिसे कहते हैं सोडियम हाइड्रोफॉस्फाइड मिल गया। उसके बाद फिर आता है कि white phosphorus is less stable and therefore more reactive than the other solid phase under normal condition because of the angular strain in the P4 molecule where the angles are only 60 degree. It rarely catches fire in the air to give dense white fumes of the P4O10. जैसे P4 plus 5O2 को मिलाएं तो P4O10 मिल गया। It consists of the discrete tetrahedral P4 molecule as shown in the figure 7.2. यह है white phosphorus का स्ट्रक्चर, और रेड phosphorus is obtained by heating white phosphorus at 573 Kelvin per in an inert atmosphere for several days. When the red phosphorus is heated under high pressure, a fringe of the phases of the black phosphorus is formed. Red phosphorus possesses high iron gray luster. It is odorless, non-poisonous, and insoluble in water as well as in the carbon disulfide. Chemically, red phosphorus is much less reactive than the white phosphorus. It does not glow in the dark. It is polymeric consisting of the chains of the P4 tetrahedra linked together in the manner as shown in the figure 1.3. तो रेड phosphorus के लिए आ जाता है, ये ऐसा हो जाता है रेड phosphorus जो कि tetrahedral manner में linked है। फिर आता है ब्लैक phosphorus. Black phosphorus has two forms, alpha black phosphorus and the beta black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated in a fillet tube at 13 Kelvin. It can be sublimate in air and has opaque monoclinic or the rhombohedral crystal. It does not oxidize in the air. Beta black phosphorus is prepared by heating white phosphorus at 473 Kelvin per under the high pressure. It does not burn in the air up to the 473 Kelvin. फिर आता है phosphine preparation. Phosphine is prepared by the reaction of calcium phosphide with the water or the phosphine is prepared by the reaction of calcium phosphide with the water or the dilute HCl. जैसे CH3P2 plus H2O, इन दोनों को इन दोनों को रिएक्ट करने पर मिलेगा COH2 प्लस PH3 और CH3P2 प्लस HCl, इसको फिर CaCl2 प्लस PH3 मिल जाएगा, ये मिल जाएगा। उसके बाद फिर आता है इन द लेबोरेटरी इट इज प्रिपेयर्ड बाय हीटिंग भाट फॉस्फोरस विद कंसनट्रेटेड NOH सॉल्यूशन इन द इनर्ट एटमॉस्फेयर ऑफ द CO2, जैसे P4 प्लस NOH प्लस H2O को मिलेगा PH3 प्लस NH2 PO2, जिसे कहते हैं सोडियम हाइपोफॉस्फाइट। और ये रिएक्शन हो गया P4 प्लस NOH प्लस H2O gives the PH3 plus NH2 plus PO2. When pure it is non-inflammable but becomes inflammable owing to the presence of the P2H4 or the P4 vapors. To purify it from the impurities, it is observed in the HI to form the phosphonium iodide PH4 ions, which on treating with the KOH gives off phosphines. If PH4I plus KOH gives the Ki plus H2O plus PH3. Properties की it is a colorless gas with rotten fish smell and is highly poisonous. It explodes in contact with the surface of the oxidizing agents like the HNO3Cl2 and the Br2 vapors. It is slightly soluble in the water. The solution of the PH3 in the water decomposes in the presence of the light, giving red phosphorus and H2 when absorbed in the copper sulfate or the mercury chloride solution. The corresponding phosphides are obtained, जैसे CuSO4 प्लस P3 Cu3P2 प्लस H2SO4 मिलेगा, और HgCl2 प्लस P3 को करेंगे बढ़ेंगे तो Hg3P2 प्लस HCl मिलेगा। Phosphine is weakly basic and like ammonia gas gives the phosphonium compounds with the acid, और PH3 प्लस HBr को मिलेगा PH4Br। फिर उसके बाद इसका यूजेज आता है कि the spontaneous combustion of the phosphine is technically used in the whole signal containers containing calcium carbide and the calcium phosphide are biased and thrown in the sea when the gas is burned and served as the signal. It is also used as a smoke screen. In Bhatt way, can it be proved that PH3 is basic in nature? PH3 reacts with the acids like the HI to form the PH4I, which show that it is basic in the nature. If a PH3 plus HI gives the PH4I. Due to lone pair of the phosphorus atom, PH3 is acting as a Lewis base in the above reaction. In text question, bond angle in the PH4 plus is higher than that of the PH3. Why? What is formed when PH3 reacts with an acid? What happens when phosphorus is heated with concentrated NOH solution in an inert atmosphere of the CO2? And the phosphorus halides. Phosphorus forms two types of halides, PX3X is equal to fluorine, chlorine, bromine, iodine, and the PX5X जहाँ हो जाएगा फ्लोरीन, क्लोरीन और द ब्रोमीन, लेकिन आयोडीन नहीं। तो phosphorus trichloride का प्रिपरेशन, phosphorus trichloride it is obtained by passing dry chlorine over the heated white phosphorus, तो जिससे मिलेगा P4 प्लस Cl2 मिल जाएगा PCl3। उसके बाद फिर इट इज ऑल्सो ऑब्टेन्ड बाय द एक्शन ऑफ द thionyl chloride विथ white phosphorus, और रिएक्शन है कि P4 प्लस FeCl2 PCl3 प्लस FO2 प्लस F2Cl2 मिलेगा, जिसे thionyl chloride कहते हैं। फिर इसका प्रॉपर्टी है कि इट इज कलरलेस ऑयली लिक्विड एंड हाइड्राइज इन द प्रेजेंस ऑफ द मॉइस्चर, जैसे PCl3 प्लस H2O करेंगे तो H3PO3 प्लस HCl मिलेगा। फिर इट रिएक्ट्स विद द ऑर्गेनिक कंपाउंड्स कॉन्टेनिंग OH ग्रुप सच एज दी C3COOH F2H5OH, C3COOH प्लस PCl3 C3COCl प्लस H3PO3 मिलेगा, और C2H5OH प्लस PCl3 C2H5Cl प्लस H3PO3 मिलेगा। ये रिएक्शन है। उसके बाद फिर इट हैज ए pyramidal शेप एज शोन इन विच phosphorus is sp3 hybridized. phosphorus pentachloride PCl3 का स्ट्रक्चर ये हो गया। फिर प्रिपरेशन, phosphorus pentachloride is prepared by the reaction of the Bhatt phosphorus with excess of the dry chlorine, जैसे P4 प्लस Cl2 मिल जाएगा PCl5। उसके बाद फिर आता है इट कैन ऑल्सो बी प्रिपेयर्ड बाय द एक्शन ऑफ द FO2Cl2 ऑन द फास्फोरस, जैसे P4 प्लस FO2Cl2 मिल जाएगा PCl5 प्लस FO2। Properties: PCl5 is a alloys Bhatt powder, and in much there it hydrolyzes to POCl3 and finally gets converted to phosphoric acid. PCl5 plus H2O POCl3 plus HCl मिलेगा और POCl3 plus H2O H3PO4 plus HCl मिल जाएगा। तो इसका रिएक्शन हो गया। When heated it sublimes but decompose on a stronger heating, जैसे PCl5 को हीट करने पर PCl3 plus Cl2 मिल जाएगा। It reacts with the organic compounds containing the OH group converting them to the chloro derivative, जैसे C2H5 plus PCl5 रिएक्ट करने पर C2H5Cl POCl3 प्लस HCl मिलेगा और CH3 PCl5 C3COCl POCl3 प्लस HCl मिल जाएगा। ये इसका रिएक्शन हो गया। फिर फाइनली डिवाइडेड metals on heating with PCl5 give the corresponding chloride, जैसे Ag plus PCl5 AgCl plus PCl3 मिलेगा। फिर Fn plus PCl5 FnCl4 plus PCl3 मिलेगा यहाँ से भी। It is used in the synthesis of some organic compounds, जैसे compounds such as C2H5Cl or CH3COCl. In the gaseous and the liquid phase, it has a trigonal bipyramidal structure as shown. The three equatorial PCl bonds are equivalent, while the two axial bonds are longer than the equatorial bonds. This is due to the fact that the axial bonds pair suffers repulsion as compared to the equatorial bonds. और इसका जो ये हो गया वो 240 पिकोमीटर और ये जो है 202 पिकोमीटर, ये 240 पिकोमीटर हो गया। इसको कहेंगे एक्सियल। इक्वेटोरियल जो है छोटा है, इक्वेटोरियल 202 पिकोमीटर, जो एक्सियल वाला है 240 पिकोमीटर है। सो क्वेश्चन है कि why does PCl5 fumes in the moisture? तो PCl3 dies in the presence of the moisture giving fumes of the HCl, जैसे PCl3 plus H2O H3PO3 plus HCl बना देगा। फिर उसके बाद आता है कि all the 5 bonds of the PCl molecule equivalent. Justify your answer. PCl5 has a trigonal bipyramidal structure and the 3 equatorial PCl bonds are equivalent, while the 2 axial bonds are different and longer than the equatorial bonds. In text question क्या है कि what happens when the PCl5 is heated? Write a balanced equation for the reaction of the PCl5 with the water. Oxo acids of the phosphorus. Phosphorus forms a number of the oxo acids. The important oxo acids of the phosphorus and with their formulae, methods of preparation, and the presence of the some characteristic bonds in the structure are given in table 1.5. जैसे हाइपोफॉस्फोरस या फॉस्फेनिक H3PO2 फिर ऑर्थोफॉस्फोरस H3PO3 जिसको फॉस्फोनिक कहेंगे, पायरोफॉस्फोरस H4P2O5, फिर हाइपोफॉस्फोरिक H4P2O6, ऑर्थोफॉस्फोरिक H3PO4 एंड द पायरोफॉस्फोरिक H4P2O7, मेटाफॉस्फोरिक HPO3 के N हो जाएगा। ऑक्सीडेशन ऑफ स्टेट फॉर द फॉस्फोरस कैरेक्टरिस्टिक बॉन्ड्स एंड द नंबर ऑफ प्रिपरेशन दे हैं। जैसे है कि हाइपोफॉस्फोरस फॉस्फोनिक H3PO2 को भाट P प्लस अल्कली से करेंगे, ऑर्थोफॉस्फोरस फॉस्फोनिक H3PO3 को P2O3 प्लस H2O से करेंगे और पायरोफॉस्फोरस को PCl3 प्लस H3PO3 से करेंगे। फिर हाइपोफॉस्फोरिक को करेंगे रेड PO4 प्लस अल्कली से और ऑर्थोफॉस्फोरिक को P4O10 प्लस H2O से करेंगे। फिर आता है पायरोफॉस्फोरिक को हीट फॉस्फोरिक एसिड से करेंगे और फॉस्फोरस एसिड प्लस Br2 हीट इन द फिलेट ट्यूब से करेंगे। फिर आता है एग्जिस्ट इन द polymeric form only the characteristic odors of the HPO3 have been given in the table. The composition of the oxo acids are interrelated in terms of the loss or the gain of the H2O molecule or the O atoms. The structure of some important oxo acids are given next. In the oxo acid phosphorus tetrahedrally surrounded by the other atoms, all these acids contain at least one P-double bond and one POH bond. The oxo acid in which the phosphorus has lower oxidation state less than +5 contain in addition to P-double and POH bonds either PPH4 in H4P2O6 or the PH-H3PO2 bonds but not both. The acids in the +3 oxidation state of the phosphorus tend to disproportionate to higher and the lower oxidation state. For example, orthophosphorus acid or the orthophosphorus acid on heating disproportionate to give the orthophosphoric acid or the phosphoric acid with the phosphine, जैसे H3PO3 H3PO4 प्लस PH3 मिल जाएगा। अब आता है कि सबका स्ट्रक्चर दिया हुआ है, जैसे ऑर्थोफॉस्फोरिक एसिड का स्ट्रक्चर, ऑर्थोफॉस्फोरिक एसिड का स्ट्रक्चर, ऑर्थोफॉस्फोरिक एसिड का स्ट्रक्चर, पायरोफॉस्फोरिक एसिड का स्ट्रक्चर, ऑर्थोफॉस्फोरस एसिड का स्ट्रक्चर, हाइपोफॉस्फोरस एसिड का स्ट्रक्चर, पायरोफॉस्फोरस एसिड का स्ट्रक्चर, साइक्लोट्राइमेटाफॉस्फोरिक एसिड का स्ट्रक्चर और द पॉलीमेटाफॉस्फोरिक एसिड HPO3 का स्ट्रक्चर। इसमें एक डबल ओ बॉन्ड, फिर एक डबल ओ बॉन्ड, पी डबल ओ बॉन्ड एक है, पी डबल ओ बॉन्ड इसमें भी एक है, पी डबल ओ बॉन्ड इसमें भी एक है, POP बॉन्ड है, पायरोफॉस्फोरस एसिड H4P2O5, P2O5 को तो पायरो कहते भी हैं, तो H4P2O5 में, और साइक्लोट्राइमेटाफॉस्फोरिक एसिड में एक 3 गो है, तो एक पी डबल एक पी डबल और एक पी डबल, यानी 3 गो ही हो गया। फिर पॉलीमेटाफॉस्फोरिक एसिड HPO3N में पी डबल, फिर पी डबल, फिर पी डबल, ऐसे करके चलते चल जाएगा। इसके बाद फिर आता है दी स्ट्रक्चर ऑफ द सम इम्पॉर्टेंट ऑक्साइड्स ऑफ द फास्फोरस दिया हुआ है। द एसिड विच कंटेन pH बॉन्ड हैव अ स्ट्रॉन्गर रिड्यूसिंग प्रॉपर्टी, thus the hypophosphorus acid is a good reducing agent as it contains 2 pH and the reduces for example AgNO3 to metallic silver। जैसे AgNO3 प्लस H2O प्लस H3PO2 वो Ag में कर देगा, HNO3 प्लस H3PO4 में कर देगा, रिड्यूस कर देगा। These pH bonds are not unable to give the H plus and do not play an important role in the basicity. Only those H atoms which are attached with the oxygen in the pure H form are ionizable and cause the basicity. Thus the H3PO3 and the H3PO4 are dibasic and tribasic respectively, as the structure of the H3PO3 has 2 POH bond and the H3PO4 में 3 है, 3। तो एग्जाम्पल एक 1.9 है कि हाउ डू वी अकाउंट फॉर द रिड्यूसिंग बिहेवियर ऑफ द H3PO2 ऑन द बेसिस ऑफ द स्ट्रक्चर। तो इन H3PO2 2 H atoms are bonded directly to the P atoms which imparts reducing character to the acid. In text question, what is the basicity of the H3PO4? What happens when H3PO3 is heated? Group 16 elements. Group 16 elements, oxygen, sulfur, selenium, tellurium, polonium and the livermorium constitute group 16 of the periodic table. This is sometimes known as the group of chalcogens. The name is derived from the Greek word for the brass and points to the association of sulfur and it congeners with the copper. Most copper minerals contains either oxygen or the sulfur and frequently the other members of the group. तो ऑक्यूरेंस क्या है, तो ऑक्सीजन इज द मोस्ट अबुंडेंट ऑफ ऑल एलिमेंट्स ऑन द अर्थ। ऑक्सीजन फॉर्म्स अबाउट 46.6% by mass of the earth crust. Dry air contains 20.946% oxygen by the volume. However, the abundance of the sulfur in the earth crust is only 0.03 to 0.1%. Combined sulfur is used primarily as the sulfate such as the gypsum CSO4.2H2O, Epsom salt MgSO4.1H2O, barite BeSO4 and sulfide such as the galena PbF, zinc blends with ZnF, copper pyrite CuFeF2. Traces of the sulfur occurs in the hydrogen sulfide in the volcanoes. Organic materials such as the eggs, protein, garlic, onion, mustard, hair and the wool contain sulfur. Selenium and the tellurium are also found as the metal cyanides and tellurides in the sulfide or polonium occurs in the nature as a decay product of the thorium and the uranium minerals. Livermorium is a synthetic radioactive element. Its symbol is Lb, atomic number 116, atomic mass 292 and the electronic configuration Rn5146010F2p4. It has been produced only in a very small amount and has been short life, only a small fraction of 1 second. This limits the study of the properties of the Lv. Here, except for the livermorium, important atomic and the physical property of other elements of the group 16 along with their electronic configuration are given in table 1.6. Some of the atomic, physical and the chemical property of the trends are discussed below. तो some physical property of the group 16 elements जो है वो दिया हुआ है। अब आता है कि एटॉमिक नंबर, atomic mass, electronic configuration, covalent radius, ionic radius, electron gain enthalpy, ionization enthalpy, electronegativity, density, melting point, boiling point and oxidation state, ऑक्सीजन का, सल्फर का, सेलेनियम का, टेल्यूरियम का और पोलोनियम का दिया हुआ है। फिर सिंगल बॉन्ड, अप्रोक्सीमेट वैल्यू एट मेल्टिंग पॉइंट, ये सब दिया हुआ है। मोनोक्लिनिक ऑक्सीजन फॉर ऑक्सीडेशन ऑफ +2 and +1 in the oxygen fluids of the OF2 and the O2F2 respectively। अब उसके बाद फिर आता है इलेक्ट्रॉनिक कन्फिगरेशन। The elements of the group 16 and the elements of the group 16 have 6 electrons in the outermost shell and have enough to NP4 general electronic configuration. Atomic and ionic radii due to increase in the number of the shells. Atomic and ionic radii increases from the top to the bottom in the group. The size of the oxygen atom is however exceptionally small. उसके बाद फिर आता है ionization enthalpy. The ionization enthalpy decreases down the group. It is due to the increase in the size. However, the chemist elements of this group have lower oxidation ionization enthalpy values compared to those of the group 15 in the corresponding periods. This is due to the fact that group 15 elements have been extra stable half-filled p orbitals electronic configuration. Electron gain enthalpy. Because of the compact nature of the oxygen atom, it has less negative electron gain enthalpy than the sulfur. However, from the sulfur onwards, the value of again becomes less negative up to the polonium. Electronegativity. Next to the fluorine, oxygen has the highest electronegativity value amongst the other elements within the group. Electronegativity decreases with an increase in the atomic number. This implies that the metallic character increases from the oxygen to the polonium. फिर आता है एग्जाम्पल. Elements of the group 16 generally show lower value of the first ionization enthalpy compared to the corresponding periods of the group 15. Why? Due to the extra stable half-filled p orbitals electronic configuration of the group 15 elements, larger amounts of energy required to remove electrons compared to the group 16 elements. फिर physical properties. Some of the physical properties of the group 16 elements are given in table 1.6. Oxygen and sulfur are non-metals, selenium and thulium are metalloids, whereas polonium is a metal. Polonium is a radioactive and is short-lived, half-life 13.8 days. All these elements use allotropy. The melting and the boiling points increase with the increase in the atomic number. Down the group, the large difference between the melting and the boiling points of oxygen and sulfur may be explained on the basis of their atomicity. Oxygen exists in the diatomic molecule, whereas sulfur exists as the polyatomic molecule. F8. Chemical property. Oxidation of state and the trends in the chemical reactivity. The elements of the group 16 use the number of the oxidation of state. The stability of the minus two oxidation of state decreases on the group. Polonium hardly shows minus two oxidation of state since the electronegativity of the oxygen is very high. It shows only negative oxidation of state minus 2 except in the case of the OF2 where its oxidation of state is plus 2. Other elements of the group use plus 2 to plus 4 plus 6 oxidation of state, but plus 4 and plus 6 are more common. Plus sulfur, selenium and the tellurium usually 4 plus 4 oxidation of state in the compounds with oxygen and plus 6 with the fluorine. The stability of the oxidation plus 6 oxidation of state degrades down the group and the stability of the plus 4 oxidation of state increases. In that very fact, bonding in the plus 4 and the plus 6 oxidation of state is primarily covalent. Anomalous behavior of the oxygen. The anomalous behavior of the oxygen, like the other members of the p block present in the second period, is due to the small size and the high electronegativity. One typical example of the effect of the small size and the high electronegativity is in the presence of strong hydrogen bonding in the H2O, which is not found in the H2F. उसके बाद फिर आता है कि द absence of the d orbitals in the oxygen limits its covalency to the 4 and practice rarely exceeds 2. On the other hand, in the case of the other elements of the group, the valence shell can be expanded and covalence exceeds 4. Reactivity with the hydrogen. All the elements of the group 16 forms the hydrides of the type H2E, जहाँ E बराबर ऑक्सीजन, सल्फर, सेलेनियम, tellurium or the polonium. Have some properties of the hydrides are given in table 1.1. Their acidic character increases from the H2O to H2T. The increase in the acidic character can be explained in the terms of the decrease in the bond enthalpy for the dissociation of the He bond down the group. Owing to the decrease in the enthalpy for the dissociation of He bond down the group, the thermal stability of hydrides also decreases from the H2O to H2PO. All the hydrides except water possess reducing property, and this character increases from the H2F to H2TE. तो मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, H2E, HEH एंड डिसोसिएशन और डिसोसिएशन कांस्टेंट दिया हुआ है. इधर दिया हुआ है, इधर H2O, H2F, H2Fu और H2TE दिया हुआ है. फिर आता है कि reactivity with the oxygen. All the elements form the oxides of the EO2 and the EO3 type of the where E बराबर sulfur, selenium, trillium or the polonium, ozone, O3 and the sulfur dioxide are the gases, while selenium dioxide is solid. Reducing property of the dioxide again from FO2 TO2. FO2 is reducing while the TO2 is oxidizing agent. Besides CO2 type, sulfur, selenium and trillium also form EO3 type oxides, FO3, FeO3, TO3, both types of oxides are acidic in the nature. Reactivity towards the halogen elements of the group 15 forms a large number of the halides of the type EX6, EX4, EX2, where E is an element of the group and X is an halogen. The stability of the halides decreases in the order following chlorine, bromine, or iodine. Among hexahalides, the hexafluorides are the only stable halides. All the hexafluorides are gases in the nature. They have octahedral structure. Sulfur hexafluoride is exceptionally stable for the steric regions. Amongst the tetrafluorides, SF4 is a gas, F4 is a liquid, and TF4 is a solid. These fluorides have sp3 dehybridization and thus have trigonal bipyramidal structure in which one of the equatorial position is occupied by a lone pair of electrons. The geometry is regarded as the C-star geometry. All elements 4 except oxygen form dichlorides and dibromides. These dihalides are formed by the sp3 hybridization and thus have tetrahedral structure. The well-known monohalides and the dimeric nature. Uh, Examples are the FF2, F2Cl2, F2Br2, Fe2Cl2, and Fe2Br2. The dimeric halides undergo disproportionation as given below. और फिर Fe2Cl2 जैसे टूटेगा तो FeCl4 प्लस Fe2 बनाएगा. H2S is less acidic than the H2T. Why? Example 7.11 है. Due to the decrease in the bond, each bond dissociation enthalpy down the group, acidic character increases. In text question, list the important source of the sulfur. Write the order of thermal stability of the halides of the group 15 element. Why H2O liquid and H2S is a gas. फिर आता है dioxygen. Preparation dioxygen can be obtained in the laboratory by the following ways. कि पहला by heating oxygen containing salts such as the collates, nitrates and the permanganates. जैसे KClO3 को हीट करेंगे MnO2 के साथ तो हमको बन जाएगा KCl प्लस O2 बन जाएगा. उसके बाद फिर आता है कि by the thermal decomposition of the oxides of the metal low in the electrochemical freeze and higher oxides of the sulfur. जैसे Ag2O से Ag प्लस O2 बन जाएगा, HgO से Ag प्लस O2 बन जाएगा, PbNO Pb3O4 से PbO प्लस O2 बन जाएगा, अब PbO2 से PbO प्लस O2 बन जाएगा. इसके बाद फिर आता है ये वाला हो गया. उसके बाद फिर आता है हाइड्रोजन peroxide is readily decomposed into water and dioxide by catalysts such as the finely divided metals and manganese dioxide. जैसे H2O2 को गर्म H2O2 को करेंगे H2O प्लस O2 मिलेगा. उसके बाद फिर आता है ऑन लार्ज स्केल इट कैन बी प्रिपेयर्ड फ्रॉम द एयर और वाटर और द एयर. इलेक्ट्रोलाइसिस ऑफ वाटर लीड्स टू द रिलीज ऑफ द हाइड्रोजन एट द कैथोड एंड द ऑक्सीजन एट द एनोड. Industrially, dioxide is obtained from the air by first removing carbon dioxide and water vapor, and then remaining gases are liquefied and fractionally distributed to give dinitrogen and the dioxygen. Properties. Dioxygen is a colorless and odorless gas. Its solubility in the water is to the extent of 3.08 cm3 in the 100 cm3 water at 293 Kelvin, which is just sufficient for the vital support of marine and aquatic life. It liquefies at 19 Kelvin and freezes at 55 Kelvin. Oxygen atom has 3 stable isotopes, O16, O17 and the O18 molecular oxygen. O2 is unique in being paramagnetic in spite of having even number of the electrons. Dioxygen directly reacts with nearly all metals and the non-metals except some metals, example AuPt, and some noble gas. Its combination with other elements is often strongly exothermic, which helps in the sustaining the reaction. However, to initiate the reaction, some external heating is required as bond dissociation enthalpy of the oxygen double bond is high. Some of the reactions of the dioxygen with the metals, non-metals and the other compounds are given. जैसे Ca plus O2 CaO, Al plus O2 L2O3, P4 plus O2 P4O10, C plus O2 CO2, ZnS plus O2 ZnO plus SO2 and the CH4 plus O2 CO2 plus H2O. ये बन जाएगा. इसके बाद आता है सब कंपाउंड्स आर कैटालिटिकली ऑक्सीडाइज. फॉर एग्जांपल FO2 प्लस O2 V2O5 के बाद FO3 बनेगा और HCl प्लस O2 CuCl2 के बाद CuCl2 रिएक्शन करने पर Cl2 प्लस H2O बन जाएगा. फिर यूजेज है कि इन एडिशन टू दी इट्स इंपॉर्टेंस इन द नॉर्मल respiration and combustion process, oxygen is used in the oxo-acetylene building in the manufacture of the many metals, particularly of steel. Oxygen cylinders are widely used in the hospitals, high altitude flying and in the mountaineering. The combustion of the fuels, for example hydrogens in the liquid oxygen, provide tremendous thrust in the rocket. In text question, which of the following did not react with the oxygen directly? और कंप्लीट द फॉलोइंग रिएक्शन। फिर आता है सिंपल ऑक्साइड। A binary compound of the oxygen with another element is called oxide. As I already stated, oxygen reacts with almost most of the elements of the product table to form the oxide. In many In many cases, one element forms two or more oxides. The oxides are widely in the nature and properties. Oxides can be simple, जैसे MgO, Al2O3 और mixed, जैसे P3O4, Fe3O4. Simple oxides can be mixed on the basis of their acidic, basic, or the amphoteric character, and oxides that combines with the air to give an acid is termed acidic oxide, जैसे FO2 हो गया, Cl2O7, CO2, N2O5 for example. FO2 combines with the water to give the H2SO4 जो कि एक H2SO3 and acid. FO2 plus H2O रिएक्शन करेगा तो हमको मिलेगा H2FO3. फिर आता है एज ए जनरल रूल ओनली नॉन मेटल ऑक्साइड्स आर एसिडिक बट ऑक्साइड्स ऑफ सम मेटल इन द हाई ऑक्सीडेशन स्टेट आल्सो हैव एसिडिक कैरेक्टर, जैसे Mn2O7, Cr2O3, B2O5. द ऑक्साइड्स विच गिव ए बेस विथ वाटर आर नोन एज बेसिक ऑक्साइड्स. Na2O, COO, BO या फॉर एग्जाम्पल COO combines with the water to give the COOH2 a base, जैसे CaOA प्लस H2O मिलकर बनेगा COOH2. In general, metallic oxides are basic. Some metallic oxides exhibit a dual behavior, therefore characteristic of both acidic as well as the basic oxides. Such oxides are known as amphoteric oxides. They react with the acids as well as the alkalis. For example, Al2O3 reacts with the acids as well as the alkalis. जैसे Al2O3 plus HCl NH plus H2O मिला के बनेगा AlH2O6 3 plus Cl minus, और Al2O3 plus NOH plus H2O मिला के बनेगा Na3LOH6, ये बन जाएगा. उसके बाद फिर आता है कि देयर आर सम ऑक्साइड्स विच आर नाइदर एसिडिक नॉर बेसिक. सच ऑक्साइड्स आर नोन एज द न्यूट्रल ऑक्साइड्स. एग्जांपल्स ऑफ द न्यूट्रल ऑक्साइड्स फॉर द CONO एंड द N2O. फिर आता है ओजोन कि ओजोन इज एन एलोट्रोपिक फॉर्म ऑफ द ऑक्सीजन. इट इज टू रिएक्टिव टू रिमेन फॉर द लॉन्ग इन द एटमॉस्फेयर एट सी लेवल एट अ हाइट ऑफ अबाउट 20 kilometers. It is formed from the atmospheric oxygen in the presence of the sunlight. This ozone protects the earth's surface from extensive concentration of the ultraviolet radiation. और प्रिपरेशन करना है तो when a flow dry stream of the oxygen is passed through a silent electrical discharge, conversion of oxygen to ozone 100% occurs. The product is known as the ozonized oxygen. जैसे O2 plus 3O2 और ये हो गया हीट ऑफ दी enthalpy है. Since the formation of the ozone from oxygen is an endothermic process, it is necessary to use a silent electrical discharge in its preparation to prevent decomposition. If the concentration of the ozone greater than 10% are required, a battery of ozonizers can be used and pure oxygen जिसका boiling point 101.1 केल्विन है, 101.1 केल्विन है, can be condensed in a vessel surrounded by the liquid oxygen. फिर आता है इसका properties कि pure ozone is a pale blue gas, dark pale liquid and violet black solid. Ozone gas is a characteristic smell and in a small concentration it is harmless. However, if the concentration rises above about 100 parts per million, breathing becomes uncomfortable, resulting in the headache and the nausea. So ozone is thermodynamically unstable with respect to the oxygen, since its decomposition into oxygen results in the liberation of the heat. Delta H is negative and increase in the entropy delta F is positive. These are two effects reinforce each other, resulting in the large negative gives energy change delta G for the conversion into oxygen. It is not really surprising, therefore, high concentration of ozone can be dangerously explosive. Due to the use with each liberates atoms of the nascent oxygen, O3, O2 plus 4, it acts as a powerful oxidizing agent. For example, it oxidizes lead sulfide to the lead sulfate and iodide ions to the iodine. जैसे PbF प्लस O3 PbFO4 प्लस O2 बनाता है, और I माइनस प्लस H2 प्लस O3 OH माइनस प्लस I2 प्लस O2 बनाता है. तो ये इसका रिएक्शन हो गया. फिर आता है when ozone reacts with an excess of the potassium iodide solution buffered with a borate buffer pH 9.2, iodine is liberated which can be titrated against a standard solution of the sodium thiosulfate. This is quantitative method of the estimating the O3 gas. अब आता है experiments have shown that nitrogen oxides, particularly nitrogen monoxide, combines very rapidly with ozone, and there is thus the possibility that nitrogen oxides emitted from the exhaust system of the supersonic jet airplanes might be slowly depleting the concentration of the ozone layer in the upper atmosphere. जैसे NO plus O2 NO plus O3 NO2 plus O2 बना दे रहा है। Another threat to the ozone layer is probably posed by the use of the freons, which are used in the aerosol spray and as the refrigerants. The two oxygen bond lengths in the ozone molecule are identical, 128 picometer है और and the molecule is angular and spectral with a bond angle of 117 degree. It is resonance hybrid of the two forms. उसके बाद फिर आता है ये इसका ओजोन का स्ट्रक्चर दिया हुआ है। ओजोन का ये स्ट्रक्चर हो गया resonance structure। फिर यूज क्या है तो it is used as a germified disinfectant and for sterilizing water. It is also used for the bleaching oils, ivory, flour, starch, etc. It acts as an oxidizing agent and in the manufacture of the potassium permanganate. In-depth question है कि why does the O3 act as a powerful oxidizing agent? How is O3 estimated quantitatively? उसके बाद फिर आता है सल्फर का एलोट्रोपिक फॉर्म। तो सल्फर forms numerous allotropes of which the alloramic alpha sulfur or monoclinic beta sulfur form are the most important. The stable forms at the room temperature is romic sulfur, which transforms to monoclinic sulfur when heated above 359 Kelvin. Aromic sulfur, alpha sulfur. This allotrope is yellow in the color, melting point 385.8 Kelvin and a specific gravity 2.06. Romic sulfur crystals are formed on evaporating the solution of raw sulfur in the CF2. It is insoluble in water but dissolves to some extent in the benzene, alcohol and the ether. It is readily soluble in the CF2. फिर monoclinic sulfur जिसको बीटा सल्फर भी कहते हैं, its melting point is 393 Kelvin. Its melting point is 393 Kelvin and a specific gravity 1.98. It is soluble in the CF2. This form of the sulfur is prepared by melting romic sulfur in a dish and cooling till crust is formed. Two holes are made in the crust and the remaining liquid poured out. On removing the crust, colorless needle-shaped crystals of beta sulfur are formed. It is stable above 359 Kelvin and transforms into the alpha sulfur below it. Conversely, alpha sulfur is stable below 359 Kelvin and transforms into the beta sulfur above this. At 359 Kelvin, both the forms are stable. This temperature is called the transition temperature. Both rhombic and the monoclinic sulfurs have effect molecules. These effect molecules are packed to give the different crystal structure. The effect rings in both the forms is puckered and is cone shaped. The molecular dimensions are given in table 1.5a. The structure of the effect rings in the rhomic sulfur and the six ring का, तो ये दिया हुआ है effect ring और ये दिया हुआ है six ring का दिया हुआ है। उसके बाद फिर आता है कि several other modification of the sulfur containing 6 to 20 sulfur atoms per rings have been synthesized in the last 2 decades. In the cyclo-F6, the ring adopts the chair form and the molecular dimensions are shown in the figure 1.5b. At elevated temperature 1000 Kelvin, F2 is dominant species and is paramagnetic like the O2. Which forms of the sulfur shows paramagnetic behavior? So in the vapor state, sulfur partially exists as F2 molecule which has two unpaired electrons in the anti-bonding pi molecular star orbitals like O2 and hence exhibits the paramagnetism. So sulfur dioxide preparation. Sulfur dioxide is formed together with a little 68% sulfur trioxide when sulfur is burnt in the air or the oxygen. फिर रिएक्शन है कि F plus O2 FO2 बना देगा। उसके बाद फिर इन द लेबोरेटरी इट इज रेडली जनरेटेड बाय ट्रीटिंग सल्फाइड विथ डाइल्यूट सल्फ्यूरिक एसिड, जैसे FO3 माइनस प्लस 2H प्लस H2O प्लस FO2 बना देगा। उसके बाद फिर आता है इंडस्ट्रियली इट इज प्रोड्यूस्ड एज ए बाई प्रोडक्ट ऑफ द रोस्टिंग ऑफ द सल्फाइड और, जैसे FeF2 प्लस O2 Fe2O3 प्लस 8FO2 बना देगा। फिर आता है कि द गैस आफ्टर ड्राइंग इज लिक्विफाइड अंडर प्रेशर एंड स्टोर्ड इन द स्टील सिलेंडर। प्रॉपर्टी इसका है कि द सल्फर डाइऑक्साइड इज ए कलरलेस गैस विथ पंजेंट स्मेल एंड इज हाईली सॉल्युबल इन द वाटर। इट लिक्विफाइज एट द रूम टेम्परेचर अंडर ए प्रेशर ऑफ 2 एटमॉस्फेयर एंड बॉइल्स एट 263 Kelvin. Sulfur dioxide when passed through water forms a solution of sulfurous acid, जैसे FO2 plus H2O H2FO3 बना देगा। It reacts readily with the sodium hydroxide solution forming sodium sulfide, which then reacts with more sulfur dioxide to form the sodium hydrogen sulfide, जैसे NOH plus FO2 Na2FO3 plus H2 बनाएगा, फिर Na2FO3 plus H2 plus FO2 NaHFO3 बना देगा। फिर आता है in its reaction with the water and the alkali, the behavior of the sulfur dioxide is very similar to that of the carbon dioxide. Sulfur dioxide reacts with the chlorine in the presence of the charcoal, which act as a catalyst to give the sulfuryl chloride FO2Cl2. It is oxide to sulfur dioxide by the oxygen in the presence of the vanadium sulfur oxide catalyst. और रिएक्शन FO2 प्लस Cl2 FO2Cl2 बनाएगा, फिर FO2 प्लस O2 V2O5 के प्रेजेंस में FO3 बना देगा। उसके बाद फिर आता है कि when most sulfur dioxide behave as a reducing agent, for example it converts into Rn3 to Rn2 ions and decolorize the acidified potassium permanganate solution. The latter reaction is convenient in the test for the गैसेज। जैसे Fe3 प्लस FO2 और H2O मिलाया तो Fe2 प्लस बन गया, Fe3 प्लस FO2 प्लस बन गया, प्लस FO2 माइनस प्लस 4H प्लस बन गया, और FO2 प्लस MnO4 माइनस प्लस H2O FO4 2 minus plus 4H plus 2 Mn2 plus बन गया। तो the molecule of the FO2 is angular, it is ionic solid, इसका 2 canonical forms है। जैसे ये दोनों canonical form इसका, ये दोनों canonical forms इसका ये दिए हुए हैं। फिर यूजेज sulfur dioxide is used in the refining petroleum and sugar, in the bleaching wool and silk, and as an anti-chlor disinfectant and preservative. Sulfuric acid, sodium hydrogen sulfide and calcium hydrogen sulfide industrial chemicals are manufactured from the sulfur dioxide. Liquid SO2 is used as a solvent to dissolve a number of the organic and the inorganic chemicals. So in-text question is what happens when the sulfur dioxide is passed through an aqueous solution of the Fe3 plus salt, or comment on the nature of the two FO bond formed in the FO2 molecule. Are the two FO bonds in this molecule equal? How is the presence of the FO2 detected? फिर आता है ऑक्सो एसिड्स ऑफ द सल्फर। Sulfur forms a number of the oxo acids H2SO4, H2SO3, H2F2O3, H2F2O4, H2F2O5, H2SO6 जहाँ x बराबर 2 to 5 है, फिर H2FO4, H2F2O7, H2FO5, H2F2O8. Some of the acids are unstable and cannot be acylated. They are known in the aqueous solution or in the form of their salts. The structure of some of the important oxo acids are shown in the figure. जैसे ऑक्सो एसिड ऑफ दी सल्फरस एसिड दिया हुआ H2SO3, सल्फ्यूरिक एसिड H2SO4 पर ऑक्सो डाइसल्फ्यूरिक एसिड H2F2O8 दिया हुआ है। अब पर ऑक्सो पायरोसल्फ्यूरिक एसिड जिसको ओलियम कहते हैं, जिसका है H2F2O7 है। ये सब स्ट्रक्चर ऑफ दी सम इम्पॉर्टेंट ऑक्सो एसिड्स ऑफ दी सल्फर दिए हुए हैं। तो यह हो गया तुम्हारा F बॉन्ड इसमें है, F बॉन्ड इसमें है, फिर F दुदुगो है, F फिर F दुदुगो है, फिर यहाँ भी F दुदुगो है, फिर F यहाँ पर है, और फिर F फिर एक यहाँ पर है। फिर उसके बाद आता है सल्फ्यूरिक एसिड। मैन्युफैक्चर कैसे करेंगे सल्फ्यूरिक एसिड का? तो सल्फ्यूरिक एसिड वन ऑफ द मोस्ट इंपॉर्टेंट इंडस्ट्रियल केमिकल्स वर्ल्ड वाइड। Sulfuric acid is manufactured by the contact process, which involves three steps: burning of the sulfur or the sulfides in air to generate FO2, conversion of FO2 to FO3 by the reaction with oxygen in the presence of the catalyst V2O5, and absorption of the FO3 in the H2SO4 to give the oleum, जिसे कहते हैं H2F2O7 कहते हैं oleum का। A flow diagram for the manufacture of the sulfuric acid is shown in the figure 1.7. The FO2 purified is purified by removing dust and the other impurities such as the arsenic compounds. The key steps in the manufacture of the H2F2O4 is the catalytic oxidation of FO2 with the O2 to give the FO3 in the presence of the V2O5 catalyst. जैसे FO2 plus O2 V2O5 और FO3 बना देगा, जिसका हीट इंथैल्पी जो है -196.6 किलोजूल पर मोल है। The reaction is exothermic, reversible, and the forward reaction leads to a decrease in the volume. Therefore, the low temperature and high pressure are the favorable conditions for the maximum yield. But the temperature should not be very low, otherwise the rate of reaction will become slow. In practice, the plant is operated at a pressure of 2 bar and a temperature of 720 Kelvin. The FO3 gas formed from the catalytic converter is observed at a concentrated FO4 to produce the oleum. Dilution of the oleum with the water gives the H2SO4 of the desired concentration in the industry. The two steps are carried out simultaneously to make the process of the continuous one and to reduce the cost को reduce करने के लिए। तो FO3 प्लस H2SO4 को मिलाने पर H2F2O7 बनेगा, जिसको हम ओलियम कहते हैं, और सल्फ्यूरिक एसिड ऑब्टेन्ड बाय द कॉन्टैक्ट प्रोसेस जो है 96 to 98% प्योर है। तो ये है उसका फ्लो डायग्राम। और द फ्लो डायग्राम फॉर द मैन्युफैक्चर ऑफ द सल्फ्यूरिक एसिड। यहाँ सल्फर है, यहाँ एयर डालें, फिर सल्फर बर्नर है, इसको इम्प्योर FO2 प्लस O3 डालें, और डस्ट प्रेसिपिटेटर है, फिर बाफिंग एंड कूलिंग वाटर है, बेस्ट वाटर वाटर स्प्रे किए कॉन्सनट्रेटेड F2SO4 स्प्रे डाले इसमें। फिर ड्राइंग टावर बेस्ट एसिड है, फिर ड्राई FO2 प्लस FO2 डालें। फिर आर्सेनिक प्योरीफायर कॉन्टेनिंग प्लेटिनम हाइड्रेटेड फेरोसल्फेट है, ऊपर हीटर है, V2O5 हो गया, कैटालिटिक कन्वर्टर हो गया, FO3 कॉन्सनट्रेटेड H2SO4 इक्वाटेज हो गया, इधर ओलियम H2F2O7 निकल जाएगा। फिर इसका आ जाता है प्रॉपर्टीज। प्रॉपर्टीज में देखें तो क्या आता है कि sulfuric acid is colorless, dense, oily liquid with a specific gravity of 1.8 at 298 Kelvin. The acid freezes at 283 Kelvin and boils at 611 Kelvin. It dissolves in the air, water with the evolution of a large quantity of the heat. Hence, the care must be taken with while preparing the sulfuric acid solution from the concentrated sulfuric acid. The concentrated acid must be added slowly into the water with the constant of stirring. The chemical reactions of the sulfuric acid as a result of the following characteristic: low volatility, a strong acidic character, a strong affinity for the water, ability to act as an oxidizing agent in aqueous solution, and sulfuric acid ionizes in the two step में। पहले H2SO4 plus H2O मिला के H3O प्लस और H2SO4 माइनस बना, K1 वेरी लार्ज है, K1 जो है ग्रेटर देन 10 है, फिर HFO4 माइनस aqueous प्लस H2O और H3O प्लस SO4 माइनस बन गया। ये इसका हो गया। फिर आता है द larger value of the Ka1 greater than 10 means that the H2SO4 is largely dissociated into H plus and the HFO4 minus. Greater the value of the dissociation constant K1, the stronger is the acid. The acid forms two species of the salts, normal sulfate such as the sodium sulfate and the copper sulfate, and acid sulfate, example sodium hydrogen sulfate. Sulfuric acid, because of its low volatility, can be used to manufacture more volatile acids from their corresponding salts, जैसे MX प्लस H2SO4 HX प्लस M2SO4, जहाँ X इक्वल टू फ्लोरीन क्लोरीन और दी नाइट्रेट है, और M जो है यहाँ पर मेटल हो जाता है। फिर आता है concentrated sulfuric acid is a strong dehydrating agent. Many wet gases can be dried by passing them through the sulfuric acid, provided the gas do not react with the acid. Sulfuric acid removes water from the organic compounds. Sulfuric acid removes water from the organic compounds, which is evident by the charring action on the carbohydrate, जैसे कि C12H22O11 शुगर है, इस पर H2SO4 अगर डाल लेते हैं तो बन जाता है 12C प्लस 11H2O बन जाता है। Hot concentrated sulfuric acid is moderately a strong oxidizing agent. In this respect, it is intermediate between the phosphoric and the nitric acids. Both metal and non-metals are oxidized by the concentrated sulfuric acid, which is reduced to the FO2. जैसे Cu plus H2SO4 concentrate किए तो CSO4 plus SO3 plus H2O मिल गया, जैसे F plus H2SO4 FO2 plus H2O मिला, और C plus H2SO4 concentrate किया तो CO2 plus SO2 plus H2O मिल गया। तो ये इसका रिएक्शन हो गया। इसके बाद फिर आता है कि यूज देखते हैं सल्फ्यूरिक एसिड का। तो सल्फ्यूरिक एसिड इज अ वेरी इंपॉर्टेंट इंडस्ट्रियल केमिकल। ए नेशंस इंडस्ट्रियल स्ट्रेंथ कैन बी जजेड बाय द क्वांटिटी ऑफ द सल्फ्यूरिक एसिड इट प्रोड्यूसेज एंड कंज्यूम्स। इट इज नीडेड फॉर द मैन्युफैक्चर ऑफ द हंड्रेड्स ऑफ द अदर कंपाउंड्स एंड इन मैनी industrial process. The bulk of the sulfuric acid produced is used in the manufacture of the fertilizers, yes, ammonium phosphate, superphosphate. Other uses are in the petroleum refining, manufacture of the pigments, paints, and the dye stuff, intermediates, detergent industry, metallurgical application, example cleansing metals before enameling, electroplating, and the galvanizing. A storage battery in the manufacture of the nitrocellulose products and in the laboratory reagents. फिर आता है कि भाट हैपन्स, एग्जाम्पल है कि क्वेश्चन है कि भाट हैपन्स व्हेन द concentrated H2SO4 is added to the calcium fluoride, FO3 is passed through the water, it forms the, तो सॉल्यूशन है कि इट फॉर्म्स द हाइड्रोजन फ्लोराइड, और जिसका रिएक्शन जाता है CF2 प्लस H2SO4 CSO4 प्लस 2HF, इट डिवॉल्व्स FO3 टू द H2SO4, जिसका रिएक्शन फिर जाता है FO3 प्लस H2O H2SO4। फिर इंटेक्स्ट क्वेश्चन है कि mention the three areas in which H2SO4 plays an important role. Write the condition to maximize the yield of the H2SO4 by the contact process. Why is Ka1 less than Ka for the H2SO4 in the water? अब आता है ग्रुप 17। तो फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, एस्टाटीन एंड द tennessine are the member of the group 17. These are collectively known as the halogens. Greek halo means the salt and gens means the boron. That means salt producers. Group 17 elements fluorine, chlorine, bromine, iodine, and astatine and the tennessine are the members of the group 17. These are collectively known as the halogens. ग्रीक में हेलो का मतलब होता है साल्ट और जीन्स का मतलब होता है बॉन जैसे साल्ट प्रोड्यूसर्स. The halogens are highly reactive non-metallic elements like the group 1 and 2. The elements of the group 17 show great similarity amongst themselves. That much similarity is not found in the elements of the other group of the periodic table. Also, there is regular gradation in the physical and the chemical properties. Astatine and the tennessine are the radioactive elements. Occurrence क्या है? तो fluorine and the chlorine are fairly abundant, while bromine and iodine less. Fluorine is present mainly in the insoluble fluorides, fluorspar CF2, chlorides Na3LF6, and the fluoroapatite CA3PO4K2 CF2, and a small quantity are present in the soil, river water, plants, and the bones and the teeth of animals. Sea water contains chlorides, bromides, and the iodides of the sodium, potassium, magnesium, and the calcium. But is mainly sodium chloride solution. 2.5% by mass. The deposits of the dried up sewage chloride contains 2.5% of mass. The deposits of the dried up sewage contains these compounds, for example sodium chloride and the carnallite, KCl, MgCl2, 6H2O. Certain forms of the marine life forms contain iodine in their system. Various seaweeds, for example, contains up to 0.5% of the iodine, and the chill saltwater contains up to 0.2% of the sodium iodide. Here, important atomic and the physical property of the group 17 elements other than the tennessines are given along with their electronic configuration. Tennessine is a synthetic radioactive element. Its symbol is Ts, atomic number 117, atomic mass 294, and the atomic configuration Rn 5 14 6 detention F2 7p5. One very small amount of element could be prepared. Also, its half-life is in milliseconds only. That is why its chemistry could not be established. फिर आता है कि atomic and the physical properties of the halogens. Atomic and the physical property of the halogens. Atomic number दिए हुए हैं. Atomic mass, electronic configuration, covalent radius, ionic radius, ionization enthalpy, electron gain enthalpy, electronegativity. फिर melting point, boiling point, density, distance, bond dissociation, enthalpy वगैरह दिया हुआ है. फ्लोरीन हो गया, क्लोरीन हो गया, ब्रोमीन, आयोडीन और दी एस्टैटिन हो गया. तो radioactive Pauling scale for the liquid at temperature given in the parenthesis solid half solid सब दिए हुए. फिर the trends of the sum of the atomic physical and the chemical property are discussed below. उसके बाद फिर आता है कि electronic configuration. All these elements have 7 electrons in their atomic shell, enough to NP5, which is 1 electron short of the next noble gas. The halogens have the smallest atomic radii in their respective periods due to maximum effective nuclear charge. The atomic radius of the fluorine, like the other elements in the second period, is extremely small. Atomic and the ionic radii engage from the fluorine to the iodine due to the increasing number of the quantum shells. Ionization enthalpy. They have little tendency to lose electron. They have very high ionization enthalpy due to increase in atomic size. Ionization enthalpy decreases on the group. Electron gain enthalpy. Halogens have maximum negative electron enthalpy in the corresponding periods. This is due to the fact that atoms of the element have 1 electron less than the stable noble gas configuration. Electron gain enthalpy of the elements of the group becomes less negative than the group. However, the negative electron gain enthalpy of the fluorine is less than that of the chlorine. It is due to the small size of the fluorine atom. As a real, there are a strong interelectronic repulsion in the relatively small 2p orbitals of the fluorine, and thus the incoming electrons do not experience much attraction. फिर आता है electronegativity. They have very high electronegativity. The electronegativity decreases down the group. The electronegativity decreases down the group. Fluorine is the most electronegative element in the